Auzubillahiminash-shaytanir-rajim. Bismillahir-Rahmanir-Rahim. Dear student, Assalamu alaikum. Today I will discuss various chemical reaction of thiophene. Contents of today's lecture include various chemical reaction of thiophene. Thiophene undergo various types of chemical reaction. The first one is the electrophilic substitution reactions, and thiophene undergo various electrophilic substitution reaction like benzene, because thiophene is also aromatic and consists of 6 pi electron and have planar structure. So it's undergo various electrophilic substitution reaction like benzene, and it undergo sulfonation, acylation, nitration, and halogenation. And halogenation include both chlorination, bromination, and iodination. The second types of reaction is reaction with aldehyde and ketone. The third type of reaction is oxidation in the presence of per-acid or hydrogen peroxide. And the fourth one is metallation with butyl lithium. And the last one is reaction with maleic anhydride, and it reacts with maleic anhydride to produce the Diels-Alder product. So I will discuss these reactions one by one. So first I will discuss about the various electrophilic substitution reaction. Sulfonation. Thiophene can sulfonate it in the presence of phosphorus pentachloride and sulfochloridic acid. Here it is mentioned phosphorus pentachloride and sulfochloridic acid. In the presence of these two reagents, thiophene undergo sulfonation, and 70% of this sulfonated thiophene molecule is formed. The second one is acylation. The efficient acylation of thiophene takes place in the presence of acylating agent, which is an acyl chloride or acetic anhydride, and tin tetrachloride instead of aluminum chloride. Tin tetrachloride is suitable reagent which is used as a catalyst instead of the Lewis acid aluminum trichloride, because in the presence of aluminum chloride, thiophene generate tars. The polymerization take place. So to avoid polymerization of thiophene, tin tetrachloride is used instead of aluminum trichloride. So this is the reaction when the thiophene is treated with any acylating agent such as acyl chloride in the presence of tin chloride instead of aluminum trichloride. Then the Fredder-Karp acylation takes place and the substitution occurs at its alpha position. Acylation with anhydride catalyzed phosphoric acid is also an efficient method. So not only in the presence of tin tetrachloride and acylating agent, the thiophene is acylated, but the acylation can also take place when the thiophene is reacted with anhydride. It is mentioned over here that when thiophene is treated with acetic anhydride using phosphoric acid catalyst, then 80% of the acylated thiophene molecule is formed. So acylation of thiophene takes place in the presence of any acylating agent, either acyl chloride or acetic anhydride, but in these both the cases the catalysts are different. In the presence of acyl chloride, tin tetrachloride is used as a catalyst, while in case of acetic anhydride, phosphoric acid is used as a catalyst. And for the acylating agent acyl chloride, we do not use aluminum trichloride, which is the basic catalyst for Fredder-Karp acylation, because thiophene is more reactive and it generates tar. The polymerization takes place in the presence of aluminum trichloride. So therefore, generally, tin chloride is recommended to use for the acylation of thiophene molecule. Acylation will smear Hake reaction, and when the thiophene is treated with phosphorus trichloride, oxychloride in the presence of dimethyl formamide, then the aldehyde is substituted at its alpha position, and the reaction is similar to the reaction of furan. When furan is treated with dimethyl formamide and phosphorus oxychloride, then the same product, the furan is substituted at its alpha position with aldehyde. So in a similar way, the thiophene also react with phosphorus oxychloride and dimethyl formamide and produce this alpha substituted thiophene molecule. The mechanism is mentioned over here, that in the first step, the thiophene is treated with dimethyl formamide and phosphorus oxychloride and producing this alpha substituted aldehyde thiophene molecule. Mechanism involve many steps. In the first step, phosphorus oxychloride is treated with dimethyl formamide, and the lone pair of electron present on the nitrogen shift over here. So this lone pair of electron attack on this phosphorus atom, so producing an intermediate species. And in the second step, when this bond shift toward here, when this electron shift toward here, then the Cl2 eliminated and producing this species. So when this pi electron shift toward the nitrogen atom, the carbon carrying positive charge, and now it is a good electrophile. Now the sulfur pi electron of the thiophene molecule, when this non-pair of electron shift toward here, this pi electron shift toward here, and this pi electron attack on this carbon atom and producing a various resonating form of this intermediate species. And at the end, when a hydrogen is eliminated from here, we obtain this product, and from this product, this species is eliminated, dimethyl amine chloride, and producing the produces the thiophene molecule having aldehyde at its alpha position. So this is also an acylation reaction of the thiophene molecule, that the thiophene molecule can also be acylated in the presence of phosphorus oxychloride and dimethyl formamide. Next is nitration. The nitration of thiophene takes place smoothly in the presence of acetyl nitrate and nitronium tetraborate. Nitration of thiophene in the presence of nitric and nitric acid can lead to an explosive reaction. Therefore, generally, the nitration takes place in the presence of nitrating agent acetyl nitrate and nitronium tetraborate. The reaction is mentioned over here, that when thiophene is treated with acetyl nitrate at minus 10 degrees centigrade in the presence of acetic anhydride, then 70% of alpha substituted nitrothiophene is formed and 5% of beta substituted nitrothiophene is formed. And the high yield of 70% of the alpha substituted nitrothiophene is formed, because in this case, when the substitution takes place at its alpha position, the intermediate form have more resonating structure as compared to its beta position. So therefore, the major product is the nitrothiophene molecule. When the nitronium ion from acetyl nitrate or from nitronium tetraborate is treated with thiophene at its alpha position, then the resonating form, one can see over here that 3 resonating form is intermediate is formed, and one can see that the positive charge exists on the carbon atom, and in this case at alpha position, and then in sulfur, so 3 resonating intermediate is formed. While when it is substituted at its beta position, only 2 intermediate resonating form is producing. So therefore, generally the substitution, the nitration takes place at its alpha position. So the electrophilic substitution reaction, nitration, is take place at its alpha position, and the high yield is produced when the nitration takes place at its alpha position. Next is halogenation. And halogenation include chlorination, bromination, and iodination. First, I will discuss about the chlorination. Thiophene is directly chlorinated with chlorine gas either in acetic acid or carbon tetrachloride solvent, yielding a mixture of polychlorinated product. As one can see, when the thiophene is treated with chlorine gas at 50 degrees centigrade for around 8 to 9 hours, 2 types of product is formed, and it is polychlorinated, as it is chlorinated at position 1, 2, and 4 position, while In this case, it is substituted at all position 2, 3, 4, and 5 position. So the polychlorinated product is formed when thiophene is treated with chlorine at around 50 degrees centigrade. Chlorination of thiophene with sulfuryl chloride give a mixture of 2-chloro and 2,5-dichlorothiophenes. When it is heated, the thiophene is heated with sulfuryl chloride. It gives a mixture of 2-chlorothiopene and 2,5-dichlorothiopene molecule. However, chlorination with N-chlorosuccinimate in hexane at reflex mean at high temperature, give a mixture of 2,5-dichloro and 2,3,5-trichlorothiopene. As one can see over here, that when thiophene is treated with N-chlorosuccinimate, one can obtain the 2,5-dichlorosuccinimate and 2,3,5-trichlorosuccinimate molecule. But when the same reaction takes place at room temperature, it produces only 2-chlorothiopene molecule. So if we want to obtain only the one product, the 2-chlorothiopene, then we will perform this reaction, the thiophene reaction with N-chlorosuccinimate at room temperature. Chlorination with tin tetrachloride in the presence of lead tetraacetate produce 2,5-dichlorothiopene. If we want a single product 2,5-dichlorothiopene molecule, then we will treat it thiophene molecule with 10 tetrachloride and in the presence of lead tetraacetate to produce a single product. Next is bromination. Bromination of thiophene is much faster than chlorination, and bromination with N-bromosuccinimate in hexane at room temperature give 2-bromothiopene, while in ether with a 48% hydrogen bromide at -10 degrees centigrade produce 2,5-dibromothiopene. So if we want to obtain the 2-bromothiopene, we will use hexane solvent as room temperature, and if we want to obtain the 2,5-dibromothiopene, then we will treat it thiophene with N-bromosuccinimate in ether solvent with 48% hydrogen bromide and at low temperature -10 degrees centigrade to obtain the 2,5-dibromothiopene. However, bromination of thiophene with bromine and chloroform delivered 2,3,5-tribromothiopene, which on reduction with zinc and acetic acid give 3-bromothiopene. While with sodium borohydride and lead triphenylphosphine, it produced 2,3-dibromothiopene molecule. Bromination of thiophene with hydrogen bromide in the presence of an oxidizing agent such as hydrogen peroxide exclusively produce 2-bromothiopene. All these reactions are mentioned in this figure. This is thiophene. When thiophene is treated with N-bromosuccinimate in N-hexane at room temperature, we will obtain single halogenated thiophene molecule, and the bromine is substituted at its alpha position. So we can obtain the 2-bromothiophene molecule. And when we add bromine in the presence of ether solvent at -10 degrees centigrade, then one can obtain the 2,5-dibromothiopene molecule. When when thiophene is treated with bromine in the presence of trichloromethane, one can obtain the 2,3,5-tribromo of thiophene molecule, and this molecule is when treated with sodium borohydride in the presence of palladium triphenyl tetraphenylphosphine molecule, then one can obtain the 2,3-dibromo, and if it is treated and reflects with zinc acetic acid solvent, then one can obtain the beta substituted bromothiopene molecule. So under different condition, thiophene brominated to produce various products. Next one is reaction with iodine, and the 2-iodothiophene has been obtained by addition of half of 50% aqueous nitric acid dropwise to a mixture of iodine and thiophene with vigorous stirring. When when the 2-iodo-thiophene can be obtained when the thiophene is treated with iodine and 50% of aqueous nitric acid at 90 degrees centigrade, then one can obtain the 2-iodo-thiophene molecule. Iodination of thiophene with iodine and mercuric oxide at 0 degree centigrade give mixture of 2-iodothiophene 70% and 2,5-diiodothiophene thiophene. So 70% of 2-iodothiophene is formed when the thiophene is treated with iodine and mercuric oxide. And the remaining minor product is formed, which is 2,5-diiodothiophene molecule. An easy approach for iodination of thiophene is the reaction of iodine with lithiated thiophene. And this can be produced by using thiophene when thiophene is treated with iodine in the presence of butyl lithium. So in the first step, the lithiated thiophene is formed and then the lithium is replaced by an iodine. So in the presence of various reagent and under various conditions, the thiophene undergo iodination and producing various products, the 2-iodothiophene and a mixture of 2-iodothiophene as well as 2,5-diiodothiophene depending on the condition. However, the efficient way to iodate the thiophene molecule is to use the lithiated thiophene. And this can happen when the thiophene is treated with iodine in the presence of butyl lithium to obtain the 2-iodothiophene molecule. Next reaction with aldehyde and ketone. Acid catalyzed reaction of thiophene with aldehyde and ketone produce hydroxy alkyl thiophene. As one can see that this is a general structure for the carbonyl compound. It may be an aldehyde or ketone. When the thiophene is treated in the presence of an acid, in the presence of acid, this oxygen is get protonated, this carbon is more electrophilic, then the pi electron attack on this carbon atom, and in the first step, this intermediate is produced, and then the counter ion of the acid take this proton and producing the hydroxy alkyl thiophene molecule. But under acidic condition, this molecule is decomposed. So it is not a viable route for its synthesis, for the synthesis of hydroxy alkyl thiophene, as under acidic condition, it generally decomposes. When thiophene is reacted with formaldehyde in the presence of concentrated hydrochloric acid at 0 degree centigrade, it produces methyl chlorothiophene molecule. And when the thiophene is treated with formaldehyde in the presence of ammonium chloride, then the methyl amine thiophene molecule is formed. So when the thiophene is reacted with aldehyde or ketone, any carbonyl compound under acidic condition, then it produces the hydroxy alkyl thiophene, but under acidic condition is generally decomposed. But these products are stable enough, but for these products, different conditions are used. In this case, when the formaldehyde is used, concentrated hydrochloric acid is used at 0 degree centigrade, and when ammonium chloride is used, then the methyl amine thiophene molecule is formed. Oxidation in the presence of hydrogen peroxide. The oxidation of thiophene takes place in the presence of hydrogen peroxide. The reaction is generally catalyzed by methyl trioxyrenium +7 oxidation state. And in this case, when the thiophene, the substituted thiophene is treated with hydrogen peroxide in the presence of methyl trioxyrenium ion, then one can obtain the sulfooxide thiophene. And complete oxidation takes place to sulfone by sulfoxide intermediate. This is the sulfoxide intermediate. And when the hydrogen peroxide is present in the catalyst, methyl trioxyrenium is present, then one can obtain the sulfone molecule. This reaction is reported in inorganic chemistry. The link is mentioned over here. If anyone is interested in the detail, one can download this reaction from this link. The next reaction is metallation with butyl lithium. When thiophene is treated with one equivalent of N-butyl lithium, one can obtain alpha substituted lithiated thiophene, and this lithiated thiophene is easily substituted when an electrophile at its alpha position. As I mentioned in the previous slides, that generally the nitration and other electrophilic substitution electrophile can be substituted. Any halogens, chlorine, bromine, or iodine can be substituted easily with this lithiated thiophene molecule. So when we using one equivalent of butyl lithium, the thiophene can be lithiated, and lithiated thiophene can easily be undergo electrophilic substitution reaction to produce the alpha electrophile substituted thiophene molecule. When thiophene is treated with two equivalent of N-butyl lithium, then the 2,5-dilithium thiophene molecule is formed, and when it is treated with an electrophile, one can obtain the 2,5 substituted thiophene molecule. The last reaction is reaction with maleic anhydride. Thiophene show little tendency to act as a diene in Diels-Alder reaction. However, when it is reacted with the maleic anhydride under extreme condition, it produces adduct in high yield. So this is thiophene. Thiophene generally do not have little tendency to act as a diene, but when it is treated with maleic anhydride under extreme condition at 100 degrees centigrade and 0.8 gigapascal pressure, then the Diels-Alder product form. This is the new bond form, and under drastic condition, the thiophene reacts with maleic anhydride to produce this adduct. So this is all about the chemical reaction of thiophene. In today's lecture, I have discussed about the various chemical reaction of thiophene. I have discussed the specifically the electrophilic substitution reaction, nitration, sulfonation, acylation, halogenation, and halogenation include chlorination, bromination, iodination. And then I have discussed about the reaction with aldehyde and ketones, and then oxidation reaction and reaction with maleic anhydride to produce the Diels-Alder product. These are some reference book for further study. Thank you.